Alright, welcome back. Today you will learn how to graph piecewise linear functions. And I think there's a key word in this, piece. Okay, piecewise linear functions. What you're going to be doing is graphing parts of lines or pieces of lines. Not the whole line, but just a portion of the line. Okay, now this problem given says g of x equals all of this mess. Okay, before we talk about this, let's look at g of x for a moment. All right, g of x, f of x, h of x, r of x, t of x, whatever you want to call something of x. This is a fancy way of saying what? I want you to think for right now that this is a fancy way of saying y. Okay, so f of x is just what? Y. G of x is just y. H of x is just y. I always tell students to think of g of x, h of x, f of x, t of x. That's not Texas. Okay, rather think of this as a fancy way of saying y, or y is going on a date. Okay, y is dressed up in a suit. Okay, so this is y in a red suit, this is y in a black suit, h of x is y in a green suit, or whatever. It's just a different color outfit. But g of x, f of x, h of x are all representations of y. So what are we looking at here? We're looking simply at y equals -3, y equals x, or y equals -x plus 6 if blah, blah, blah. Okay, so I want you to circle this to the right. This is called your domain. Okay, and for right now, I want you to think domain means x-axis. Okay, now to graph this function, let's go ahead and draw a graph. So tonight, all you have to do is simply graph the function. Okay, this is our x-axis, this is our y-axis, and again, over here is our domain, and g of x is a fancy way of saying y. Okay, now, let's start with the domain. What does this mean? Okay, starting with the top, it says that x is less than or equal to -4. Now, since this is our x-axis, let me put some marks here. I think probably 7 by 7 should be enough. Okay, 7 by 7, 6 by 6, somewhere in there. We're going to start with the domain x is less than or equal to -4. We read this as all values that are to the left or smaller than -4. So we're going to look on our x-axis. Where is -4 located? Okay, hopefully you say here. Okay, let's go ahead and mark this location. Now, the question is this open or is this closed? Okay, remember that less than or equal to, greater than or equal to is closed. Okay, or we use bracket to represent closed. Less than, greater than is open, and we use parentheses to indicate open. Now, since this is closed, we're going to put a bracket at -4. Okay, bracket, and we are to the left of -4. So let's put a bracket pointing to the left. Okay, what this indicates is that we're looking at the portion of the x-axis to the left of -4. Okay, now let's also look at the domain. We read this as x is between -4 and 2, or here on a number line, here's -4, here is 2. Okay, and remember we are open, so we're looking at open above -4, open above 2, everything between. Okay, so if we want to mark this portion of the x-axis, okay, we're going to start where? At -4, and we are open. So we're going to put a parenthesis at -4 to the left, I'm sorry, to the right, and a parenthesis at 2, okay? And this indicates that we're looking at the portion of the x-axis that is between -4 and 2. Now let's look at our third domain. Down here, this means all values that are greater than or equal to 3. Okay? Now we're going to find 3 on the x-axis, that is here, okay? And greater than means closed. So we are closed at 3, and we are to the right. Okay? We read this as all values that are greater than or equal to 3. So these are your specified domains. You have a domain, think of this as 3 pieces a piece that's to the left of -4, a piece that is between -4 and 2, not including the endpoints, and a piece that is greater than or to the right of 3, including 3. Okay? Now, this is your domain, but this is not the graph. This is not what we're actually graphing. This is the portions of the x-axis associated with each different line. Okay? Now, let's go ahead and I'm going to erase this for now. Okay? We're going to do this one at a time. 3. 5, 6. Now, we're going to look at our lines. We have y equals -3. So let's go ahead and write to the left. Y equals -3. That is the first line. Remember that g of x represents y. Y equals -3. We also have y equals x. So underneath this, we're going to write y equals x. Okay? And also we have g of x representing y. Y equals -x plus 6. And hopefully you can see over here the equations of 3 different lines, reminding you on the bottom one, we're looking at y equals mx plus b. Okay, so we're looking at the slope on the bottom, or the third line, we're looking at the slope of -1 and a y-intercept of 0, 6. Okay? Starting with the first line, y equals -3, hopefully you remember from the last video that y equals -3 represents a horizontal line. Okay? A horizontal line where? A horizontal line at -3. Now, I'm going to show you 2 different ways to do this. The first way is to draw the entire line, then erase. Okay? We can draw the entire line, then we can erase part of the line. We can draw the entire line, and we can erase. We don't want to burn erasers, so I'm going to show you a more efficient way to do this. But starting with y equals -3, this is a horizontal line where? At -3. So if you put your pencil horizontally on your graph, remember this is a horizontal line at 0, a horizontal line at 1, it's a horizontal line at 2, or we say the equation of this horizontal line is y equals 0, y equals 1, y equals 2, y equals 3. So we're looking at the horizontal line y equals -3. Is y equals -1, y equals -2, we are here. Okay, so if we draw this line, y equals -3, okay, if I can label it to the right so that you can see, this is the line, y equals -3. Now we look at our domain. For the line y equals -3, our domain, it says if we're on this domain, the domain is all values of x that are less than or equal to -4. So going back to this portion of the x-axis, remember, we are closed and we are to the left of -4. Okay, here's -4. We are closed, which is a bracket, to the left. We're looking at the portion of the x-axis that is to the left of -4. Okay, also including -4. So my question is, what part of this line is associated with this portion of the x-axis? Here you can see it. We're asking what part of this line is associated with this portion of the x-axis, meaning what part of this line is either above or below this portion of the x-axis. Okay, so I tell students go straight down from -4, straight down from -4, and cut off your line here. Okay? And then notice, we agree that the piece of the line that is to the left, okay, the piece of the line that is to the left is associated with this portion of the x-axis. Notice, this portion of the line, okay, is associated with this portion of the x-axis. That is the part of the line that we want. We don't want the portion that's to the right, but we say we want the piece of the line that is to the left of -4. Notice piecewise function. Okay, so we want the piece of the line that's to the left of -4. We are going to erase everything that's to the right, okay, in the equation. I'm going to go ahead and erase the equation. So we want the piece of the line that's left of -4. Now question, is this open or is this closed? Remember, bracket means what? Closed. Okay, so we're going to put a closed dot on the end of this line, and we have successfully graphed the piece of the line that is associated with this portion of the x-axis. Now, which part of this is the graph, or which part of this is the function? Is the bracket, this portion of the x-axis the function, or is the line itself? Okay, I want you to understand the line is the function, not the portion of the x-axis. So I'm now going to erase this. Okay. And so now we see we have graphed this piece of the line. Okay. The domain is just for reference. It's not actually part of the graph. Okay. So what we did on the x-axis is not part of the graph, just this piece. Now, looking at the next one, we're looking at y equals. Let me erase this. We're looking at y equals x. Remember that g of x represents y. So y equals x. We are here on this line. Okay. I'm going to erase this. We're now looking at y equals x, and notice there are two variables in this equation. So this is not a horizontal line. This is y equals mx plus b. Now, you need to find, to graph this line, you need a point and you need a slope. Reminding you, y equals mx plus b, m is the value that's in front of x, or the slope is the value in front of x, okay? And so our slope here, m equals, notice what's in front of x, nothing's written, we write this, or we assume 1x. So the slope is 1, okay? And what is our b value? Okay, is there any b value written? No. I want you guys to see that y equals x is the same as writing y equals x plus 0. So what is the b value? Hopefully you say that the b value is 0. Okay, if I write, well, I wrote it here, plus 0, then our point, which is a special type of point, is a y-intercept. Remember that the first value is 0, and since b is 0, our second value is also 0. So we have the point 0, 0, and a slope of 1. We're going to graph this line. Point is 0, 0, slope is 1. Okay, our point is 0, 0, which is the origin. Slope is 1 means rise 1, up, go up 1, go right 1. Okay, our rise is 1, our run is 1. So up 1, right 1. Okay, up 1, right 1. Okay, you can do it again. Up 1, right 1. Also, you can go down 1, left 1. Down 1, left 1. And again. And again. Okay, and let's do it one more time. Okay, so we've got all these points. Now, if you graph your line, I'm going to show you that graphing the line is not the most efficient way to do this. If you graph the line, you have to erase, and we want to save eraser. We don't want to burn all of our eraser. Now, we're going to look at the domain. So for the line y equals x, let's look at the domain. Okay, it's the middle domain. We're looking at x is between -4 and 2. Okay, open, open. Okay, so we established this. Let's find -4. Okay, at -4 we are open, pointing to the right. Okay, notice the parentheses open. Okay, pointing to the right, and open at 2. Okay, so at 2 we are open and to the left. So we're looking at everything between. Now my question is, what portion of this line is associated with this portion of the x-axis? We look above it and we look below it. Okay, above and below. Now, question, is this point inside the domain, or is it in between -4 and 2 on the x-axis? Hopefully you say yes. Okay, this portion. I tell students this, go straight up and go straight down and make marks. So if we go straight above -2, cut it off. I'm sorry, straight above 2, cut it off. Go straight below -4, straight down, and cut it off. Okay? Notice, if we erase this portion of the line that's to the right, okay, and we erase this portion of the line that's to the left, can you see that this piece of the line is associated, it's kind of a geometrical thing, you have to see this, guys, between -4 and 2. So below -4, we've cut off any portion of the line that's to the right, and above 2, up here, we've cut off any portion of the line that's to the right of 2. Okay, now, question, does parenthesis mean open or closed? Hopefully you say open. Okay, so we're going to put an open circle at the end of this line, okay, or at the end of this piece. Okay, and above 2, we're also going to put an open circle, okay, to represent that this point is not included as part of the line, I should say line segment, and this point is not included as part of the line segment. Okay, so the point that is associated with an x value of 2 is not included. The point associated with an x value of -4, which is directly below -4, is not included. So again, where did we cut the line off? We cut the line off directly below -4, and we cut the line off directly above 2. Okay? And you are looking at the piece of the line that is part of this function. Now, question again, is the line the function, or is the x-axis the function? Okay? Hopefully you say that the line itself is the function, not the x-axis. So let's go ahead and erase this so as not to get confused. Okay? This is just to help us keep things in perspective. All right, so far we have graphed one piece and two pieces, and now we have to graph the third piece. All right, erasing this. You are looking at y equals -x plus 6. So let's go ahead and circle this, okay? And it's written here. Y equals -x plus 6. Let's go ahead and get our point and our slope. Remembering y equals mx plus b. Our slope, m, is equal to -1. Slope is -1. And our point is a special type of point or y-intercept. Okay, the b value is 6. Remember that a y-intercept has an x value of 0, and the b value is 6. That's our second value. So 0, 6 is our point. Let's graph our point. 0, 6 is here. Okay, and with slope is -1. So from here, we're going to go down 1, right 1. Let's do it again. Down 1, right 1. Okay, do it again. Down 1, right 1. And one more time. Down 1, right 1. Okay, and let's graph this line. It should cross actually right here. Okay, so we have graphed the line y equals -x plus 6. Now, looking over at our domain for y equals -x plus 6, the domain is x is greater than or equal to 3. Okay, now remembering greater than or equal to means closed, and we're starting at 3, and we're to the right. Greater than or equal to 3. Start at 3 on the x-axis. Okay? Start at 3, and we're going to put a bracket indicating to the right. Okay, so to the right of 3, including 3. Now my question is, what portion of this line is associated with this portion of the x-axis here? Maybe you see again, what did I say? Start at 3. Is the line above 3? Or is the line below 3? Okay, hopefully you say above 3. So we're going to go directly above 3. And we're going to cut off the line. Okay, go directly above 3 and cut off the line. Now, do we want the portion of the line that is to the right of 3? Or do we want the portion of the line that is to the left of 3? Hopefully you say, we want the portion of the line that's to the right of 3. So we're going to erase everything over here. Okay, so erase this part. What part of the line do we want to deal with? Just the part of the line that's to the right of 3. So notice we went directly above 3, cut it off. All right, now remember that bracket means closed, so let's put a closed dot on the end. Okay, and we have now successfully graphed the third piece of this function. Okay, together, all three pieces make up one function. Okay, so this is one function, and it has a name called a piecewise linear function. Okay, meaning this linear function is made up of pieces of lines. Okay, 1, 2, 3 pieces make up this function, and I think you can see now there is 1, 2, 3 pieces to this function. Okay, and each piece, all right, is made up of a different line. Okay, on a different domain. Okay, there's an individual domain. This top piece has its own domain. The middle piece has its domain, and the bottom has its domain. Okay. Now, let me show you a faster way to do this. Instead of, we don't want a burn eraser. Okay, we want to think ahead. Okay. Now, I tell students, if you want to save eraser, don't graph the line first. Look at your domain first. So let's rewrite this function. Okay. Let me see here. -3x. I can make this. So we have g of x. I'm going to rewrite it. -3 if x is less than or equal to -4. It was x if x is... Well, let me give you guys a different example. Here, let me show you another one. Okay, so we're looking at, let's use f of x. Doesn't matter. F of x is equal to 2x if x is less than or equal to -1, 5 if x is between 0 and 2, and -2x plus 1 if, let's make that -2x plus 7, or how about 3, if x is greater than or equal to 3. Let's make this here, let's make this greater than, it's less than or equal to. Alright, so we have to draw a graph. Piecewise is difficult for students at first, so if you guys are struggling with understanding this, that's okay. Okay, so piecewise is not necessarily an easy topic. It's new. Okay, it's completely different than things that you've done before. Okay, so x-axis, y-axis. What else could we call the y-axis? Instead of calling this y, we could call this what? We could call this f of x. Remember that f of x is another way of saying y. Okay, but for now, let's just call it the y-axis. Same thing. And a 6 by 6 or 7 by 7 should be enough. Okay. Now, I'll show you the easier way to do this is not to start with the line itself, y equals, remember we're looking at 3 lines here, y equals what? Y equals 2x, y equals 5, and y equals -2x plus 3. Okay. Instead of starting by graphing your lines, rather start with your domain. Okay, so we're going to look at the first line, one line at a time. So y equals 2x, starting with what domain? The domain x is less than or equal to -1. Remember, we are on the x-axis. Less than or equal to -1 means open or closed. Hopefully you say closed and to the left. So we're going to be at -1. Closed is what? Bracket. Okay, so we're looking at a portion of the x-axis that is to the left of -1. Now, let's go to our line, y equals 2x. Let's find a point in the slope. Y equals, notice that we put our domain on our x-axis first. So y equals 2x is y equals mx plus b. Reminding you, our slope is what? Slope is 2, so m is 2. We also need a point. Okay, point comes from the b value. Notice y equals 2x is the same as y equals 2x plus 0, so our b value is 0. That means that our point is 0, 0. Okay, so starting where? Starting at the origin, 0, 0. Now notice I have not actually, well, maybe this helps. Use your pencil, put very light point at 0, 0. Very light. Okay, hopefully soon you'll see that this is not necessary. 0, 0, and the slope of 2 means go up to right 1. So from here we would go up to right 1. Put a very light point, okay? And do it again, up to right 1. Question, are we getting closer to our domain? Remember, we want the piece of the line that is associated or that is above or below this portion of the x-axis that's below -1. Hopefully you say going up to right 1, going up to right 1. We're going further away from our domain. So instead of going up to right 1, what's the same as going up to right 1? We could also go what? Down to left 1. Okay? Put a very light point. Do it again. Down to left 1. Okay? Question, are we getting closer to the domain? And yes, in fact, notice we are inside of our domain now. Go directly below -1. Directly below -1. Is there a point associated with this? Yes. Is this open or is this closed? Hopefully you can say that this is closed. And we want to start here and take every point that's what? To the left. Notice, we have successfully graphed the piece of the line that is to the left of -1 without erasing anything. Well, okay, you got a couple light points here. You can maybe just lightly erase for now. Okay, but you'll get to the point where you don't have to erase anything. We had to go what? Instead of going up to right 1, if you just think about it, up to right 1, we're going the wrong way. We need to go down to left 1, down 2, left 1. Here we are. We are inside our domain. Okay? Notice that this piece of the line is directly below. Now we're looking at below or above, okay, but directly below this portion of the x-axis. Now, that's the first piece. Now let's look at the second. I'm going to erase this. The second piece is the line y equals 5. But before we deal with this, we're going to look at our domain. Domain is all values between what? All values between 0 and 2. Notice we are open at 0 and we are closed at 2. Now open means parentheses, so we're going to start at 0. We need a parenthesis at 0 and closed at 2. So we're going to be bracket or closed at 2. Notice we're looking at the portion of the x-axis that is between 0 and 2. Okay? And looking back at our line, notice we put our domain first. Now looking at our line y equals 5. Remember, there is no x term in this equation. This is a horizontal line. A horizontal line where? At 5. So if you put your pencil horizontally on your paper, where do we have to go to get to 5? Do we go down or do we go up? Hopefully you say up. This is y equals 1, y equals 2, y equals 3, y equals 4, y equals 5. Now, so we're looking at some sort of horizontal line at 5. But we want the horizontal line to be associated with this portion of the x-axis. Go ahead and put a very light point here. Do we want to put a light point to the left? Okay, question. The line is going to be running horizontally. Do we want to put points out here to the left? No. We want points that are associated with the portion of the x-axis between 0 and 2. So we're directly either above or below. Hopefully you say the line is up here, so we're directly above this portion of the x-axis. Notice we want points. We want points that are in here. Okay? Now, so we don't want points out here to the left. Question, directly above 0, are we open or are we closed? Notice we have parenthesis. Okay, so this means open. I want you to put, instead of closed, let's put an open circle. Okay, so this is open. Up. This is open. And we're directly to the right until we get where? Until we get to 2. So directly above 2, we are closed. We're closed, okay? And we have successfully graphed a piece of the line. This is the piece of the line that is directly associated with this portion of the x-axis from 0 to 2. So directly above. Notice we are open at 0, and we are closed at 2. Okay? Now, you can erase this. You can erase this. Remember that this is not part of the function. Okay, lastly, third line. Okay, before we graph the third line, we're going to look at our domain. Domain is all values of x that are greater than 3. Okay? So we're looking at this bottom domain. Let's mark this on the x-axis. Greater than 3 means above 3 or to the right of 3. Remember, we are open. Okay, so at 3 we are open. That's parenthesis, and we are to the right. Okay? So everything to the right of 3, and we're going to graph this line. We need a point, we need a slope. Hopefully now you can say that our slope is -2, and the point is a special type of point or y-intercept. Starting with 0, we have 0, what? 3. Okay, so let's look at this point 0, 3. Hopefully at this point you can say 0, 3, if we put a point here, are we associated with this domain over here at 0, 3? No. Okay. Now our slope is -2, so we're starting at 0, 3. Don't even put a point. Just put your pencil there to indicate where we start. We want to go down to right 1. Okay, down to right 1. Are we going the correct direction? Are we coming towards our domain? Yes. Down to right 1. Do it again. Down to right 1. Are we getting closer to our domain? Yes. Down to right 1, and we're here. Okay. Go ahead and put a point. Do it again. Down to right 1. Question, are we now inside of our domain? Yes. Notice if you didn't put a point, you didn't have to erase anything out here. You just counted. Down to right 1, down to right 1, and again, down to right 1, and we are at our domain. Is this point, I'm a little off, is this point, okay, associated with this portion of the x-axis? Well, the answer is actually no. Why? Because this is parenthesis. Parenthesis means what? Open. So this point is technically not part. At this point, we should have open, okay? But everything past this point, down to right 1, down to right 1, everything down here is part of this domain. So we're going to start open, using the slope down to right 1, graph the rest of the line. Okay, so you have successfully graphed 3 pieces. Okay, one function has how many pieces? 1, 2, 3 pieces. Okay, so this function f of x equals all of this is one function that is made up of 1, 2, 3 pieces, or you can see them here, 1, 2, 3 pieces. Okay, hopefully that helps you guys. Don't get discouraged if you struggle with this. Okay, this is something that students have a hard time with when they first look at it. So hopefully this video helps you guys get started on your homework, and give it your best effort. Good job, guys.